Units 9 through 10, Exponents and Logarithms Booklet 3. Law of Exponents. Exponent properties, the product rule. What is the difference between 3x and x cubed? Explain in complete sentences and with examples. Write your explanation in the space provided. Let's look at the table. We have product 2 to the second power times 2 to the third power. The expanded form repeated multiplication would look like this. 2 times 2 times 2 times 2 times 2. This one right here was the 2 to the second. And this one right here was 2 to the third. Put them all together, you get 2 to the fifth power. That is the exponential form. On the next one, we have 3 to the fourth, so let's write 3 4 times. And then times 3 to the fifth, so we're going to write 3 5 more times. We have 9 3's all together, so our exponential form would be 3 to the ninth power. We'll do something similar for the next one. Write 6 7's, and then 8 7's. Then we have 7 to the 14th power. Okay, this time we have 3 of them, but they're still all the same base, so we'll just write them all out. We have 5 to the 8th power. Okay, we still have the same bases. It's x this time. And as you can see, it gets really long when those exponents get larger. So we want to be able to use the rule instead when it gets to be larger numbers. Now determine a general rule for what happens when we have two exponential expressions multiply each other with the same base. You may want to write the rules in words, or you can use an example or expression to communicate the rule. Write that in this box. Pause the video and then continue after you've answered that. Why do you think this rule is called the product rule? Describe the reason why in this box. Please write the algebraic rule we came up with as a group. Here's the algebraic rule for the product rule. A to the m power times a to the n power equals a to the m plus n power. You're adding the exponents. Exponent properties, the quotient rule. We look at the first one, we have our quotient 2 to the third over 2 to the second. Expand them just like the previous page. We have 3 2's in the numerator and 2 2's in the denominator. The like factors cancel out, so those 2 2's go together, and those 2 2's go together. You're left with 1 2. So your simplified form is 2 to the first power, just 2. Let's look at the next one. We have 3 to the 7th over 3 to the 4th. Let's expand those. And then we'll cancel out the like factors. And then we're left with 3 3's. 3 to the third power. The next one has variables. Let's expand them. And then we'll cancel out the like factors. Alright, now we have 5 to the 12th power times y to the 20th power, all over 5 to the 7th power times y to the 8th power. If it gets any bigger than a power of 9, that would be too big. You want to use the formula instead. And then we have a to the 7th, b to the 3rd. You can have multiple things here. Write something out here where it has a to the 7th and b to the 3rd, and then more a's and more b's that would cancel out, and write those. Now determine a general rule for what happens when we have two exponential expressions dividing each other with the same base. You may want to write the rule in words, or you could use an example or expression to communicate the rule. Pause the video and fill in these blanks right here. Here's the algebraic rule for this one. A to the m over a to the n equals a to the m minus n. You're subtracting the exponents for this one. Exponent properties, the zero exponent rule. We have 2 to the 3rd over 2 to the 3rd. If we expand those, we have 2 times 2 times 2 over 2 times 2 times 2. If we cancel out all the like factors, everything cancels. When everything cancels when you multiply or divide numbers, the answer is 1. Let's look at the next one. Expand 5, 7 different times. And then 5, 7 times again. Everything cancels. And you're left with 1. Same thing with the x's 10th powers. Everything cancels. And you're left with 1 again. What do you think anything to the 0th power should equal? The answer is 1. Are there any exceptions to this rule? Yes, the base a cannot equal 0. If it equals 0, it's an indeterminate form. It would be undefined. Exponent properties, the power rule. On our example, we have 2 to the 2nd power to the 3rd power. Expand it to the 2nd, to the 2nd, and to the 2nd. Notice we have it 3 times here. And then further expand it. Each of those 2's is going to be 2 times. Add those all together, you get 2 to the 6th power. Let's do the next one. So 5 to the 3rd is going to be repeated 4 times. And they will further be expanded for each 5 be repeated 3 times. That's 5 to the 12th power. Seven to the 12th power. First, let's write the 7 12 times. We can group them many different ways. Let's do 7 to the 6th power. And so that would be 2 of those. And then we have 7 to the 6th power to the 2nd power. There's multiple ways to write this out. This was just one of them. You could also group them 7 to the 3rd, 7 to the 4th, 8 factors of 12. X to the 6th power is repeated 1, 2, 3, 4 times. And then we would expand it further. We get x to the 24th power. Right, 3 to the 4th, y to the 2nd, 5 times. Alright, 2z to the 3rd power 4 times. A to the 20th to the 32nd power, that is really large, so you'd want to use the formula for this one and then write the answer there in this box. Now determine a general rule for what happens when you have something already to a power, raised to a power again. You may want to write the rule in words, or you can use an example or expression to communicate the rule. Pause the video and finish filling in these boxes. How is this rule different from the product rule? Explain that here in the box provided. The formula for the formula chart is like this. A to the m power to the n power equals a to the m times n power. This is when we're multiplying exponents. There's another formula on that same formula chart from Algebra 1 where you're dividing the exponents. A to the m over n power equals the nth root of a to the m. And that's your rational exponent property. Exponent properties, negative exponents. So if we look at this example, we have 2 to the 2nd power over 2 to the 5th power. Expand them, cancel out the like factors. Everything cancels out at the top. Remember, when you divide or multiply and everything cancels, it's a 1. So that's why there's a 1 in the numerator. And then there's 3 2's left in the denominator. You could also rewrite this 2 to the negative 3rd power. To change the sign of the exponent, you flip the fraction. Let's look at the other one. A over a to the 8th. Expand. Cancel out like factors. Everything at the top cancels, so that's a 1. We'll rewrite it as 1 over a to the 7th power. A to the 1 minus 8th power, that is equal to a to the negative 7th power. The next one would be 4 to the negative 8th power. See if you can fill in an example that would give you that. Let's look at the next one. X to the 3rd power y over x to the 7th power. Alright, so that's going to reduce to y over x to the 4th power. We can write that out here as x to the 3 minus 7th power y equals x to the negative 4th power times y. Let's expand the next one. So we write a 4 times, b 5 times, all over a 9 times, and then b 12 times. Cancel all the like factors. And then rewrite it. Everything cancels at the top. It's a 1 all over a to the 5th, b to the 7th. We have a to the 4 minus 9 times b to the 5 minus 12. And then that'll give you a to the negative 5, b to the negative 7th. And then let's expand the last one. We're going to write 5 twice. Now 25 to the 4th power. That is the same thing as 5 to the 2nd power to the 4th power. So let's keep the 5 squared at the top in the numerator. And then the denominator, we're going to write 5 squared 4 times. Okay, one of those 5 squareds cancel. You're left with the 1 in the numerator, and then 5 to the 6th power in the denominator. We have 5 to the 2 minus 8. Because 2 times 4 would give you 8. 5 to the negative 6th power. Now the standard answer you would have on these types of questions would be the form that is in the 3rd column. The answer is a fraction. They usually want you to have all the exponents as positive exponents for your final answer. What does a negative exponent mean? Look at the 2 columns on the right and try to formulate a rule. Answer the next question. Are positive expressions with negative exponents negative? No. What do you think this simplifies to be? 1 over 2 to the negative 3rd power. Go ahead and take a guess or try to work it out mathematically. To check the answer, it would be 2 to the 3rd power, also known as 8. Explain why that is in this box. Here's the formula for this one. We have a to the negative n power equals 1 over a to the nth power. We're flipping the fraction, changing the sign of the exponent.